Hey guys, so we are continuing with Mystery 1, and our goal for Mysteries 1 and 2 for our new weather unit is that we are learning to show data in tables and graphs to show normal weather during a season. So, right now we're working on defining weather, thinking about weather conditions, and gathering data, and then we'll work our way up here. Okay? But again, for now, we're mostly just thinking about the weather, right? We're beginning to climb the ladder. So let's start where we left off last time.
So, as you saw in the video, clouds aren't solid or soft or fluffy. This skydiver goes right through one. I'm guessing the clue you noticed the most was all those little droplets of water on the camera lens. That's what you feel when you feel a cloud. Clouds aren't like cotton candy or smoke at all. Clouds are all watery, they're wet. So, based on everything you've seen now, it would seem that clouds have lots of tiny droplets of water in them. That's probably not too surprising. I mean, rain comes from clouds. So there must be water that somehow gets up into the sky. Now, there's plenty of water here on Earth. There's lakes and oceans and rivers. But it's not like it ever rains upwards, where you see water going from the ground up into the sky. So, how would little droplets of water get up there into the clouds? Well, take a look at this. This is a puddle of water in someone's driveway. Let's use a sped up video and watch it for a while. What happens? You see
Hmm.
that? The water in the puddle is disappearing. Now, it's worth noting this cement is solid. There's no cracks or holes for the water to drain into. So that's kind of weird. Well, have you ever seen a pot of water when you boil it? You see how something is moving up from the pot into the air? You hear this stuff called steam or water vapor. As you keep boiling the water, eventually all of the liquid water in the pot goes away and the pot will be empty. The water in the pot became this steam that was rising up. The steam rising off the top of a boiling pot of water, this is what scientists call water in its gas state. You see, water comes in three different forms or states. You already know about the other two. There's the solid state of water. That's what we call ice. Ice is still water, it's just a different form of water. It's water in its frozen or solid state. And if you melt ice, you get ordinary water itself. That's water in its liquid state. But the steam rising off a boiling pot of water, that's a third state, the gas state. We can call it water gas. Now, the gas state is when water leaves the container. It can move and go up into the air around us. This process of going from a liquid to a gas, in science, we call this evaporation. We say that the liquid water evaporates, rising up out of the container as it becomes a gas. Now, the water from this puddle example was not hot, like the boiling water, and we didn't really see anything coming off the top of it like we did with the boiling pot. So, is this the same thing? Could the water still be evaporating, escaping into the air, even if it's not boiling? Well, here's another sped up video you gotta see. This is an ordinary glass of water. You see the water level at the top? Now, let's watch what happens when this glass of water is left out on the counter for a few days. Notice what happened? The water level went down. So even though the water isn't boiling, when you leave it sitting out, it still seems to do the same thing as boiling water, just much more slowly. In fact, if you look really carefully, you can even see a little bit of it when it first rises up out of the glass. Then it spreads out into the room. And it turns out that if you use warm water in the glass, the water evaporates even more quickly. Let's try an experiment. What do you think would happen if we took a cup of warm water? So, in other words, a cup of water liquid that's becoming water gas rising up out of the cup. But now, instead of letting any of the water gas escape, let's say that we trap it. What do you think will happen if you trap some of the water gas and don't let it escape?
Good question. All right, so what do you think would happen if we trapped that water and didn't let and then let it sorry, didn't let it escape? Okay? Going to give you 10 seconds to think. If you need more time, you can hit pause. We're going to continue in 5, 4, 3, 2, 1, 0. If you need more time, again, hit pause. I'm about to hit the play. the arrow here to continue. Let's see.
In today's activity, you're going to put some warm water in a cup. That's water that's turning from a liquid into a gas. And you're going to see what happens to that water gas when you trap it underneath a lid like this. Your job, just like a scientist, is to observe what changes when you add the water and put on the lid. You'll write down and draw what you notice. Here's how to set it up step by step.
All right, so turns out we are going to have to wait to get this answer until we do our activity next week, okay? So, what you are going to do now is I want you to go to the seesaw activity with this lesson and tell us your prediction. All right, this question will be there again, but you're going to make a prediction about what you think will happen. Okay? If you have extra time before the rotation ends, you can explore more about weather on Brain Pop Jr. All right, get to work, scientists.